Okay, hello guys, grade 12s. I've got interesting question of Gauteng preparatory exam that I want us to go through. I'm going to share the screen right away so that you can see the question I'm talking about. Okay, what's happening? I'm trying to share the screen. Or you are screen sharing. So I need to see the question that I want us. There is a question. Yes, this is the preparatory exam 2024, paper 2, Gauteng province. This is the question that I want us to look at, but I will be picking trigonometry for today. We will look at other chapters in our next session. For today, we are going through Gauteng paper 2. We are looking at trigonometry. So let's go straight to trigonometry without waste of time. Let's go to the questions of trigonometry. Okay, let me try to increase. Okay, yes. Then I will need to annotate. Let me use the black. Okay, yes. So the first question, it's 5.1, which says simplify. We are given the expression to simplify. So let me give you the key idea now that you will need when you are solving this problem of 5.1. Remember, there are certain mathematical ideas, certain mathematical concepts that you need in order to solve mathematical problems. So here I will say you need the idea of what we call reduction formula. In order for you to solve the question of 5.1, the mathematical skill that you need is the skill which is called reduction formula. So this is what the examiner is testing here. They want to see if you guys have learned very well the idea of reduction formula, which will come in your final exam. Now, when we are using the idea of reduction formula, we will need another concept, or I will say, we will need to use a diagram called a cast diagram. We will need a diagram called a cast diagram. When we are working with reduction formula, we will need a diagram which is called a cast diagram. A cast diagram will be very, very, very important. So what is this reduction formula? What is this reduction formula? Because I'm saying this is the skill that you need. What is this reduction formula? Reduction formula help us to reduce the angles. It helps us to reduce the angles. So most of the time in trigonometry, we want to work with angles which are below 90 degrees. Let me give you an example. Let's say I say to you, I have this sine 235. Let me say, I want you to simplify sine 235. So the first thing that I notice here is that the angle 235 is above 90 degrees. So my goal is to reduce the angle so that it becomes below 90 degrees. How am I going to do that? I'm going to say, okay, I want to reduce sine 235 so that is below 90 degrees. Let me look at my cast diagram. Remember, I'm using the scale of reduction formula to reduce the angle. So I must involve the cast diagram. The cast diagram is going to be very, very, very important when we're working with reduction formula. So I'm going to go to the cast diagram, which is 0, 90, 180, 270, and 360. Now I'm going to say, okay, let me say in the first quadrant, which is all, this is in the first, student in the second, takes in the third, coffee in the fourth quadrant. So this is the cast diagram, and you will notice that on the cast diagram, we have got trigonometric ratios there. you see that in the first quadrant there is A, which simply means all trigonometric ratios in the first quadrant are positive. Then we go for the second quadrant, which is between 90 and 180 degrees. In the second quadrant, we are saying it is the trig ratio sign, which is positive. In the third quadrant, between 180 and 270, is the trig ratio tan, which is positive. And in the fourth quadrant, which is between 270 and 360, is the trig ratio cos, which is positive. So now, where is this 235? Remember, I want you to reduce 235. Let's not forget that we are solving sine 235. I want to reduce 235 so that it becomes the angle below 90 degrees. In which quadrant do we find the angle 235? Surely you notice that is in the third quadrant because 235 is between 180 and 270. So I will put 235 in this quadrant. The angle that I'm simplifying is in the third quadrant. So now I have a right to use 180 and 270 in my simplification. I have a right to use 180 and I have a right to use 270 because this 235 is between 180 and 270. So my first approach will be this. Let me do this. I'm going to say sine 180. I'm using 180 now to simplify the angle 235, to pull it down so that it becomes the angle below 90 degrees. So I'm going to say sine 180. I'm going to add something to 180. So that 180 plus that something which I'm adding should give me 235. What can I add 180 with so that I get 235? I'm going to add, how much am I adding? If I add 20, I'm at 200. So I have to add 35. So it's going to be 55. So it's 180 plus 55. Now, the angle of focus, guys, the angle of focus will be 55. This is the angle which I'm going to focus at because it's the angle below 90 degrees. So now I'm going to say, okay, this sine 180 plus 55 can be simplified. Somehow, this 180 disappear. You are going to be left with 55. We're going to focus on the angle 55. So we're going to say, okay, in the third quadrant, remember this 180 plus 55, which is 235, is in the third quadrant. And in the third quadrant, the trig ratio sign, this sign guy, in the third quadrant is negative. Remember, in the third quadrant, it is only tan, which is positive. Did I say only tan? It is actually tan, and it's a reciprocal called cot. But I think most of the time you guys, you don't focus at cot. So it is tan in the third quadrant, which is positive, tan and cot. So we see that sine is actually positive in the second quadrant. So in the third quadrant, I'm going to say sine is negative. So my answer is going to be negative sine 55. Which means that when we simplify sine 235, using the idea of reduction formula, we notice that our value becomes negative sine 55. So the value becomes an angle which is below 90 degrees, this is what we love in trigonometry. We love to work with angles which are below 90 degrees. So if the angle is not below 90 degrees, you can reduce it using reduction formula. Okay, this idea of reduction formula, it is of per amount. It is very, very important. And reduction formula will work all the time when you see these angles. I'm going to write all these angles down. Okay, I'm going to say sine, let me say 90 plus theta. So we can solve sine 90 plus theta using the idea of reduction formula. Let's say we have got sine 180 plus theta. We can solve sine 180 plus theta using the idea of reduction formula. I will explain what I will give you the hint of when you consider reduction formula. Let's say we have got sine 270 plus theta. Also, you go for reduction formula as well if you have sine 360 plus theta. So I want you guys to look at these angles. These angles, this 90, 180, 270, 360. When you see these angles, 90, 180, 270, and 360, you know that you have to go for reduction formula. Remember, the reduction formula goes in hand with a diagram which is called the cast diagram. So if you look at the cast diagram, we have these angles. We have 90, we have 180, we have 270, we have 360. So when you see 90, 180, 270, and 360, you know that you have to go for reduction formula. And what does the reduction formula do? It helps us to reduce the angle, to pull the angle down so that it becomes the angle below 90 degrees. So I'm going to solve this 5.1 of preparatory exam Gauteng province 2024. Let's see. We have got sine squared 180 plus x. So I'm going to say, let's think of it like this. Sine 180 plus x times sine 180 plus x. This comes from the ideas of exponents. We know that in mathematics, if we say something is squared, for example, if we say a squared, that means a times a. So if we say sine squared 180 plus x, we are simply saying sine 180 plus x times sine 180 plus x. So I can solve this one, sine 180 plus x, using which idea? Reduction formula, because of this guy here, 180. Remember I said, if you see these angles from the cast diagram, let me write down. When you see, in this case, we see 180. There is 180 here, which is there on a cast diagram. So you know reduction formula can be very helpful. And think of this x. Think of this x as an angle below 90 degrees. The x there represent the angle which is below 90 degrees. So I'm going to say, the first thing that I will ask myself, in which quadrant it's 180 plus x? Remember, I said x is any angle below 90. So you can think of it as 1. So you can say 180 plus 1. So this is 181, which means that 180 plus x is in the third quadrant. This 180 plus x is in here. Because if you add any value below 90, you add 1, you have 181, which is in the third quadrant, because 181 is between 180 and 270. You can add any value. You can even add 2. You can decide to say, let me think of 180 plus 2, which is 182. Where it's 182 in the third quadrant. X represent any angle below 90, and if you add anything 90, 180 plus anything 90 will put you in the third quadrant. So 180 plus x is in the third quadrant. And remember that in the third quadrant, it is tan, which is positive, which means the sign in the third quadrant is negative. So I'm going to have negative sine x. So this sine 180 plus x, it becomes negative sine x. this guy disappear. Boom. Our angle of focus is x. So we are left with negative sine x. There, guys, when you are dealing with reduction formula, it's very, very important to decide the sign of your trig ratio when you are working with reduction formula. Decide on the sign of your trig ratio, whether your sign is positive or whether your sign is negative. That is very, very, very important. So sine 180 plus x, we said is going to be negative sine x. And we know that negative sine x times negative sine x, it's sine squared x. It's sine squared x. So when we solve this sine squared 180 plus x, when we reduce it using reduction formula, we are left with sine squared x. So let's write that one down. I'm going to say sine squared 180 plus x, it's sine squared x. It's sine squared x times, now let us solve sine of negative x. There is a simpler way. We are still going to work with reduction formula. There is a simpler way of working with sine into negative x. Actually, there are two possibilities here. Maybe, let's say I'm not sure what my answer is. Maybe my answer can be sine x. It might be a positive trig ratio. Or maybe my answer might be a negative trig ratio. I know that one of these two is the answer. One of the two is the answer because it's very, very, very important to decide on a trig ratio. So I'm saying maybe my trig ratio is positive. Maybe my trig ratio is negative. So I have to decide on the correct sign of my trig ratio. What you can do, you can say, okay, use your calculator. You can say sine of negative, where there is x, you put any number below 90. You can put 1. You can say sine of negative 1. And you press equal sign. You check if your answer is positive or if it's negative. So if your answer is negative, some values, you know that the sign of a trig ratio is negative. So if you do that actually here, you'll notice that the correct answer is negative sine x. The sign of a trig ratio is negative. Okay, okay, ma'am. Okay. And then, okay, so let's continue, guys. Let's talk about, let's go to the fourth quadrant. I want to approach the same problem in a different manner. So let me erase. I set this sign into negative x. It's negative sine x. I said you can confirm that by simply working with your calculator. You can say sine, you press negative of a certain number, then you press equal sign. You see that your answer is negative. So the trig ratio is negative sine x. I'm going to look at a different approach now. What you can do, you can ask yourself this question. In which quadrant is negative x? And I will say to you guys, all angles that are between 0 and 90 are in the first quadrant. Those are positive angles between 0 and 90. But what about negative angles? The angles between 0 and negative 90, those are the negative angles. They are in the fourth quadrant. Those are the angle between 0 and negative 90. So remember, if you see negative x, it's actually in the fourth quadrant. How so? Because it's the angle between 0 and negative 90. Remember, this x is any number between 0 and 90. So if you say negative of that value is in the fourth quadrant, and in the fourth quadrant, it is cos, which is positive. Let me write this. All student takes coffee. This C is for the trig ratio cos. So it is cos, which is positive in the fourth quadrant. Sine in the fourth quadrant is negative. So I'm going to say, okay, this negative x is in the fourth quadrant, and in the fourth quadrant, sine is negative. So my answer is negative sine x. Okay, all over. I love this one now. I love negative sine 90 plus x. Why do I love this one? Because it's going to introduce something very, very important, which is what we call the core function of a trig ratio. You must know that the trig ratio sine, it has what we call a core function. And the core function of sine, it's cos. So we say, let me write this. Let me say sine of an angle has a core function, and the core function of sine is cos. The core function of sine is cos. I will actually explain what I've just written here. But for now, I just want you to know that the sine has a core function, it's cos. And cos has a core function, it's sine. So now, we are still on the topic of reduction formula. We want to reduce our angle. So this 90 plus x is going to be reduced. We are going to be left with angle x. The angle x is going to be the angle of focus, which is the angle below 90 degrees. So, but because of this 90, I guarantee you that the trig ratio will change. This sign will change to its core function. So guys, when you're working with reduction formula, it's very important to notice that there are points or there are circumstances where the trig ratio changes. And when does the trig ratio changes? Whenever you see 90 degrees. When you see this 90 plus x, I already know my final answer is not going to be sine of x. Nope. The trig ratio will have to change to its core function. And the core function of sine, it's cos. Okay, let's do this one. I'm going to write this negative. I'm going to say negative. Now, let's work with this one. Let's work with sine 90 plus x. I will say to you, always important to decide on the sign of your trig ratio. Let's work with sign first. Is my trig ratio going to be positive or is my trig ratio going to be negative? You have to decide on the sign of your trig ratio first. So let's go through that. We can do that by checking where is 90 plus x in the cast diagram. So let me draw my cast diagram. 0, 90, 180, 270, 360. Where is this guy 90 plus x? And we notice that 90 plus x is in the second quadrant. Do not forget that I said x represent an angle below 90 degrees. So if you say 90 plus any number below 90, you will notice that you are actually in the second quadrant. You can add 1. You can say 90 plus 1 is 91. 91 obviously is between 90 and 180. So we see that 90 plus x is in the second quadrant, and this guy's sine, the guy we see here, sine, our trig ratio sine in the second quadrant is positive. So I will say, okay, positive what? Positive cos x. Please don't say sine x. No, my trig ratio sine has to change. It has to change. It has to change because of that 90. So actually I'm having negative cos x. because this negative times this positive gives me negative. So, okay, this guy here, negative sine 90 plus x, it's negative plus x times tan x. Okay, let's continue. Let's continue, guys. Let's continue. So now, let's work with the numerator. It is sine squared x times negative sine x. Let me raise this guy here not to confuse you. Yes. It's sine squared x times negative sine x. So if, let me just say equals to, let me continue here. If I multiply these two guys, I'm going to have negative sine cube x over, I want to multiply negative cos x with tan x. Okay, in trigonometry, it's very important that when you see the trig ratio tan, you change it to sine over cos. We are using what we call a quotient identity. According to the quotient identity, tan is equal to sine over cos. So I'm going to say negative cos x, change tan, and say it's sine over cos. Then when I continue, my numerator is still sine cube x over my denominator, cos cancel cos, I'm left with negative sine x, which implies that my final answer is sine squared x. So, and notice, guys, don't do this in the exam. Notice that when I was solving my problem, I missed this guy at the end here, -1. So it means there is -1 here. There is -1. Don't worry, it won't affect your answer that much. So it's going to be sine squared x -1. So yes, sine squared x -1. They say simplify to a single trigonometric term. I just keep sine squared x -1. This is my final answer. This is my final answer. Can I do something different? Let me see. No, I'm just keeping it this way. No, I need to be very careful. Sine squared x -1, because some ideas comes here. I'm seeing sine squared x -1. My question is, do I stop here or do I continue? Okay, I know something like this one. Let me talk about this one. I know that 1 minus sine squared x, 1 minus sine squared x, it is cos squared x. So unfortunately, sine squared x -1, it is not 1 minus sine squared x, which means that now I see that actually the final answer of sine squared x -1 is going to be minus cos squared x. How can I prove this to you guys? How can I prove this to you? Let me do this so that it makes sense. Let me say sine squared x -1. I have a right to change this one. This is a very good question. I have a right to change 1 and say 1 is this guy. So it's minus. When you change something, put it in brackets. 1, it's sine squared x plus cos squared x. According to the square identity, according to the square identity, 1 is equivalent to sine squared x plus cos squared x. So most of the time, when you see sine squared x plus cos squared x, you can say it's 1. So in this case, I'm substituting 1 with sine squared x plus cos squared x. So now my problem becomes sine squared x negative times sine squared x, negative sine squared x, negative times cos squared x, negative cos squared x. Sine squared x minus sine squared x is 0, so I'm left with negative cos squared x. So this is your final answer. You have simplified your expression to a single trigonometric term, which is in terms of cos. I almost left it as sine squared x minus 1. And I noticed that this need to be solved further. But let me tell you what helped me not to stop. What came to my mind so that I do not stop. I know that if I have something like this, okay, let me pick something which you know. 9 minus 5. I know that it's 4. But if we say 5 minus 9, I know that the numerical value is the magnitude is the same, but there is a negative sign here. So 5 minus 9 is minus 4. Now look, if we know that 1 minus sine squared x is cos squared x, this means that if I take sine squared x and subtract 1, I'm going to get negative cos squared x. So this what helped me actually. I know that if a minus b, it's c, b minus a, it's minus c. So I knew, okay, here I might have to continue. Sine squared x minus 1 is negative cos squared x. Okay, I wanted to go to 5.2, but typical me, I have to summarize everything that I was talking about before we go to another problem. I don't want you guys to make a mistake of not grasping the concept of what we call reduction formula. So let me just conclude this problem of 5.1 by summarizing what we were talking about. You might have missed some ideas. Reduction formula, number 1, I said, it helps us to reduce the angle. In trigonometry, you want to work with angle below 90 degrees. So let's say you have something like this. Sine 270 plus x. I'm going to use this one to summarize everything I was talking about. So let's simplify this. Sine 270 plus x. The first thing that I notice, I know that my angle, it's above 90. 270 plus x is a certain angle above 90. We cannot be guaranteed which value it is because we don't know the x is a variable. So we don't know the real numerical value of x. But we know that 270 plus x, it's above 90. But I know, okay, it's very important to remember that x, I said it's any number below 90. X is a number below 90. So which means that I can know where is 270 plus x in my cast diagram. 90, 180, 270, 360. If you add something to 270, I guarantee you, you will be in the 4th quadrant. So now we know that the angle 270 plus x is in the 4th quadrant. And in the 4th quadrant, this guy's sign can't be positive. In the 4th quadrant, the trig ratio sign is negative. So I'm going to say negative. What I was doing, I was deciding on the sign of a trig ratio. I think this is the first thing that you must go for. Determine the sign of your trigonometric ratio, whether your sign is going to be, whether your trig ratio is going to be negative or positive. It's very important. So in this case, we say 270 plus x in the 4th and sign is in the 2nd, all students, sign is in here. In the second, this is where it is positive. It is positive in the second quadrant. In the fourth, it is negative. So that's why I say negative. Now, what is my final answer? Negative cos x. Really? Really, sir? What happened? Because we started with sine, but you are saying your final answer is in terms of cos. Yes, because of this 270, your trig ratio will change to its cofunction. Actually, there are two instances where the trig ratio change. When there is 90 and when there is 270, your trig ratio is going to change. So this is the ideas of reduction formula. And the examiner here was testing the ideas of reduction formula. I'm hoping you guys, you will grasp this concept. If there is any question, please ask me. So you can communicate with me on the YouTube channel, and let me appreciate you. Whoever listens to my mathematical ideas and concept, sharing maths with you, it's very interesting, it's very great. And I appreciate, guys, those who follow my YouTube channel. I think if you can keep following, eventually you can get there. Shalom, shalom. See you next time. I thought I will go to 5.2, but I'll see you next time. Please keep visiting my YouTube channel. I think there will be a continuous video which continue on this Gauteng province preparatory exam. Thank you so much. Let me stop sharing and then let me end the meeting.